to another session of Mathematical Literacy. Now, today we are going to be looking at a section that falls under Learning Outcome 3. And we're going to be focusing on perimeters, areas, and volumes. Now, folk, I love this section of work. It's absolutely fantastic. And why? Because we can ask you all kinds of wonderful questions on it. Questions which relate to everyday life. But be warned, some questions can be very basic. Some questions can be very easy. But some of them can be quite a challenge, especially when we're dealing with paper 2. Now, the exciting thing about this section is this, that no matter what question we ask you on perimeter, on area, on volume, the examiners are always going to give you certain formula within a question. And I want to make this clear, that if an examiner gives you a formula inside a question, so they give you a question and then say, the following formula may be used. Or they could say, use the following formula. Now, folk, when the examiner gives you a formula in a particular question, you use the formula. No examiner sets a question and then for some unknown reason throws in some weird and wonderful formula, okay? And says, let's just put this in and trick them. Never. They never do that. So if you see a formula, you're going to use it. And that's what makes this section interesting, is that the examiner is going to guide you through your questions the whole time. I always say to my students, when you see a question and they give you certain formula, make sure you've used all those formulas in that question. If you haven't, you've made a mistake. Got it? Right. Let's get started. So today we're going to be looking at perimeter, area, and volume. Before we look at any questions, and what we're going to do today is we're going to look at past questions from past papers, from the 2011 paper actually. But before we do that, let's just recap. Let's just say, what is perimeter? What is area? And what is volume? Let's have a look at this. So first of all, perimeter. You can see here on the right-hand side of my screen that I've drawn a little rectangle, okay? Now, what is the perimeter? Well, the perimeter is as if I were walking along that line, okay? So if I were to start at a point and walk along the line all the way until back to my starting point, that distance that I would have walked is my perimeter. Let's have a look at this diagram. So over here, let's say I'm going to start at this point over there. I would walk all along that line, okay, plus that distance over there, back this distance, and finally back to my starting point. Now, this whole distance is called my perimeter. Now, folk, when we deal with perimeter, we deal with units such as millimeters, centimeters, meters, maybe even kilometers, okay? Just the units by themselves, no squared, no cube, just millimeters, centimeters, meters, or even kilometers. So what's area then? Well, area, here it is here, okay, is if I were to take this rectangle, and let's get rid of these lines that I've drawn here so you can see exactly what I'm doing, okay? So where I now, and I'm going to shade it, area is this whole area or this whole space within my rectangle. So everything I'm shading, and I'm shading it in a wonderful, stunning color. I hope that comes out nicely on your screen as well. There it is. Now that is called my area. Right, so it's the inside shading of my object. Okay, now area, we would just use millimeters, centimeters, meters, and kilometers, but because it's area, we're going to say millimeters squared, centimeters squared, meters squared, kilometers squared. Now, I'm really emphasizing this, and I'll tell you why. Do you know how many students in their final exam are asked to calculate area and work it out fantastically and then say equals 10 centimeters, and they underline and they move on to the next question? And they lose a mark because what they're actually saying is, oh, examiner, I don't know that area is units squared. So don't forget that. It's a simple, basic concept, and by now you know that concept. But guys, in exams, we tend to leave them out, and we lose marks for that. Right, let's now look at this. Volume. What do I mean by volume? Well, let's pretend I've got my box again, or my rectangular shape here. Now, for volume, I've got to also have a bit of depth. Right. Okay? And my volume, I'm saying how much of something or how much space can I put inside that box? How much space is in that box? So, perimeter, the outer surface. Area, if I were to color in the front of the box. And volume is how much units can actually fit inside that box. It's a three-dimensional box. Okay? Let's have a look at this. So perimeter is measuring the distance of a line. Can you see it's only one dimension? So my units, as we said, are going to be millimeters. They could be centimeters. They could be meters. Hey, they could even be kilometers. Area is two-dimension, because to calculate area, we have to have a length and a breadth. And because it's two-dimensional, we're going to say my units are going to be millimeters squared, centimeters squared, maybe meters squared, or maybe even kilometers squared. Now, volume has three dimensions. It's got a length, it's got a breadth, and it's got a depth. So volume, we're going to say, is millimeters cubed or centimeters cubed. It could even be meters cubed. And you know what? It could even be kilometers cubed. Oops, I put a square. Cubed, there it is. Okay. Understand the basics? Two rules. Number one, use a formula if you get given it. And number two, perimeter, area, and volume are either the unit or the unit squared or the unit cubed. Let's get on with the question. So, we're going to look at the very first question, and it's adapted from November 2011. The paper one, and it was there, question 6.2. We're going to call it question 1 for our sake. Now, here we go. 2 weeks before the final hockey match, a concert was held on the hockey field. The stadium manager inspected the field after the concert and found that some of the lines on the field were unclear, and part of the grass on the field was damaged. Now, the dimensions of the hockey field are as follows. Okay? And there they are. We have a length of 98 meters, and we have a breadth of 72 meters. Okay? So let's recap, and let's just have a look, or let's try and understand this question. So, there's this club, they have a wonderful concert, and it's on the hockey field. After the hockey field, someone goes and has a look at this field and says, oi, we got a problem here with this field. Before this concert, we had wonderful lines showing the boundary of our hockey field. Now those lines have all been faded because everyone's been walking all over the place. Secondly, we got some grass that's been damaged on our hockey field. We got to do something about it. Okay, what do you think the examiner is going to ask me? I think he's going to ask me two things. I think firstly, he's probably going to ask me, how am I going to repaint, or how much paint do I need to repaint those lines? And the second thing he's probably going to ask me, he's probably going to say how much area of grass needs to be recovered. Let's see if that happens. So, there's our question. Now, first thing, let's have a look. The following formula, and I always chuckle when I read this, I'm going to put this in a different color because I really love it, may be used. Now, folk, there's a big clue here. When an examiner says it may be used, okay, what he's actually saying is, oi, you better use it. Okay? It's like when, guys, if you're watching, it's like one day when you're married, okay? And your wife comes along to you and she says to you, do you like my dress? Now, gentlemen, there is no choice in that answer, okay? You cannot think about it. You do not study the dress. It's an automatic answer. Yes, dear, lovely dress, okay? Same here with this concept. The examiner says, here's an equation, or here's a formula. Would you like to use it? Yes, sir, I'm going to use it. Okay? I don't even think about it. I'm going to use it. Right. So, he tells us the perimeter of a rectangle is equal to 2 bracket length times breadth, plus breadth. Okay? And the examiner here is quite nice. It's telling us, hey, L means the length and B means the breadth. It also goes on to say the area of a circle is pi times r squared. And it says, but don't use pi on your calculator, please. Make sure pi is equal to 3,14. All right, so what's the question? Let's go look. Now, all the outside boundary lines, the bold ones, in other words, not all the lines, only the outside lines, okay, which are actually bold in our diagram, and I'll show you just now, have to be remarked. And one of the goal areas, semicircle, important that, has to be regrassed. Now, determine the total length of the boundary lines of the hockey field that need to be remarked. So what are they actually asking me? Let's have a look at this. What he's actually saying is this. I want to find the length of this line, okay? In fact, I'm going to use a different color. Let's use green so it really shows up. I want to find the length of this line. I want to add the length of that line, add the length of that line, and add the length of this line. Okay. And the examiner, remember, gave us this formula. Said the perimeter of a rectangle. And what shape is my hockey field? It is a rectangle. So the perimeter of my rectangle is equal to 2 times length plus the breadth. So let's go here. So we're going to say, right, the perimeter is equal to 2 times the length plus the breadth equals 2 bracket. What was my length? Let's have a look at it. My length, we told, was 98 meters. So I'm going to, and the breadth is 72. So 98 meters plus 72 meters, okay, equals 2 times, what's 98 plus 72? Hey guys, let's not panic about that. Let's not try and do mental maths. Let's use our calculator. And I encourage you in your final exam, no matter how simple the question may be, use a calculator. You know why? Because when you write that final exam, you are going to get a little nervous. You're going to get a little tense. And whenever you're nervous and whenever you're tense, you tend to make careless mistakes. Right, so let's use it. I'm going to bring up my calculator here, and I'm going to say, right, so I want 98 meters plus 72 meters equals, and I get 170 meters. So I'm going to say, right, that is 170 meters. Okay? So what is 2 times 170? Well, again, my calculator is going to do it. I've got 170 times 2 equals 340. So my answer is 340 meters. Meters squared, meters cubed, or just meters? Just meters. Why? Because it's perimeter, and we're dealing with a one-dimensional line. Right, next question says this. If it takes 25 minutes to remark 8,5 meters of boundary lines, calculate how long in hours it would take to remark 100 meters of boundary line. Okay, so I've got 100 meters that needs to be remarked. I'm going to divide it by 8,5 to see how many 25 minutes I need. So I'm going to say 100 meters divided by 8,5 meters. And let's do that. So we're going to say, cool, I got 100 divided by 8.5. And I land up here with an answer of 11,76. Okay, so I need 11,76 25 little minute sessions. Cool? So what am I going to do with that 11,7? I'm going to multiply it by 25 minutes. Right. So now I can look at that 11,76, and your question paper, in the front of the question paper, would say round to 2 decimal places where necessary. So you know what I'm going to do? I'm going to round this to 2 decimal places. And I'm going to say my answer is 11,76. So I need 11,76 what? Of 25 minutes. So I'm going to take my answer, multiply that by 25 minutes. Right. How am I going to do that? Well, if you look at your calculator, I've got the 11,7647. I'm going to multiply it by 25 minutes. Now, do you see this button here? And I'm pointing to it on my screen where it looks like a circle, then a comma, comma, comma. Well, that is my time button. Okay? And my calculator will only do as it's told. So I'm going to say, I've got to tell it how many hours, and I've got no hours. So I push 0, then the time button. 25 minutes, 25, and the time button again. No seconds, time button again. Equals, and what do I get? I get an answer of 4 hours, 54 minutes, and 7,06 seconds. Okay? So it's 4 hours, 54 minutes. Let's write it here. 4 hours, 54 minutes. And how many seconds was it? 7,06 seconds. And 7,06 seconds. All right. That is my answer. 4 hours, 54 minutes, 7,06 seconds. Folks, it's time for a break. We'll see you straight afterwards. Welcome back. Trust you had a good little break. And remember, just before the break, we were busy looking at perimeters, areas, and volumes. And we're going to carry on doing that right now. Let's look at another question which came up in last year's November 2011 paper, paper 1. Okay? And it was from question 5.1. I'm calling it question 2. Let me get a different color here. I'm calling it question 2 just because we've done one question and this is the second one we're tackling today. Right, here it is. The Umgababa Men's Society is responsible for raising funds to take the mothers in the community on an outing on Mother's Day. They decide to make chocolates and sell them to the community. They use a special chocolate recipe to make either round or triangular shaped chocolates. The price of each chocolate is determined by the volume of the chocolate. The chocolates are covered with foil wrapping. The diagrams below show the dimensions of 2 different shapes of chocolate. So we have our round chocolates. There they are. Okay, and we told the radius of the cylinder is 18,5 millimeters. The height of the cylinder, what do we mean by height? That's what I mean by height, is 10 millimeters. If we look at our triangular chocolates, we told the triangular has 3 equal sides. Each side of the triangle is 50 millimeters. So this side here is 50 millimeters, and I've got 50 millimeters this side, as well as 50 millimeters that side. We told the height of the triangle, in other words, this distance here from the base to the top of my triangle, we told that is 43,3 millimeters. Okay, And we told the height of the prism is 10 millimeters. In other words, this over here, the thickness of my chocolate is going to be 10 millimeters. Now, the examiner goes on to say the following. The following formula may be used. And remember what we said before the ad break? Guys, your wife comes along to you. Do you like my dress? Yes, dear. We don't even look at it. Okay? Yes, dear. Phenomenal dress. If she says, do you think I've lost weight? Yes, dear. Okay? That is something you will never ever think about. You do not debate about it. You do not even consider the answer. It's yes, dear. Right? The examiner says to you, here's some formula. Do you want to use it? Yes, sir. Okay? Got to use it. Why? That Templeton character, Peter Templeton on TV, he said, we got to use formula if we're given it. We're given it, we're going to use it. Right. And what's they telling us? They're telling us the volume of a cylinder. Now, folk, here's my cylinder, hey? So I know I'm probably going to be asked something about the volume of it. We told the total surface area. So we've got the volume of a cylinder, the total surface area of a cylinder. Okay. We told the volume of a triangular prism and the total surface area of a triangular prism. So I already know there are 4 things the examiner's probably going to ask me in this question. Let's get on to the very first one. The first one says this. Calculate the following. The volume of a round chocolate. Now, what was that formula? Let's have a look at it. The volume of the round chocolate, which is also a cylinder, okay? So the volume of a cylinder, there she is there, is pi times r squared times height. So we're going to say, right, volume is equal to pi times r squared times the height of my chocolate. Now, the question also says, or the formula said, use 3,14 as pi. And that's what I'm going to do. 3,14 times my radius squared times my height. Now, what was the radius of that chocolate? Let's have a look. The radius of the cylinder, in other words, from the center of my chocolate all the way through to the circumference is 18,5 millimeters. And we're told the height is 10. Okay, so this over here is 10 millimeters and my radius 18,5. So let's put that in. So my radius is 18,5 millimeters, okay, and the height was 10 millimeters. What do I do now? Well, the first thing I'm going to do is I'm going to just smile and relax in the exam and say, you know what? I've got all the information I need. My job is done. Now all I got to do is bring out my calculator and it's going to do the rest of the work for me. So let's do that. Out comes our calculator and we say, right, we've got 3.14 multiplied by 18.5 squared multiplied by 10 millimeters was my height. What's my volume going to be? It's going to be 10,746,65. Now, I'll never remember that. So I'm just going to first of all say 10,746. So 10,746, comma, and it was comma 65. Comma 65. We're dealing in millimeters, okay? And because it's volume, we know got to be cubed, guys, okay? Got to be cubed. You're not wanting to lose that mark by forgetting to put the cube by the units. What's my next question? My next question says this. Find the volume of a triangular chocolate. Now, we've got to go back 2 pages, so let's do that. The volume of a triangular prism, here it is, a half, times S, times little h, times big H, okay? So we got to work out what those little s's are and things like that. So let's go for it. So volume of the cylinder is half times the side times the height times the actual depth of my chocolate. All right. So volume, S times H times H. Let's go back all the way to the next one. Volume equals S times H times capital H. Back there again. Right. And a half times that, hey? We mustn't forget a half. Why half? Because, guys, a triangle, okay, is half a rectangle. Right. So whenever we're dealing with a triangle, we've always got to have the half in front of it. So I'm going to go back and say, hey, you silly boy, you didn't do as examiner told you. So let's just get rid of this quickly. I'm going to rewrite it. And we're going to say, right, so volume equals a half times. Now, what is a half? A half is a half. We know that. Times. Let's go all the way back and get these dimensions again. Right. So each side of the triangle is 50 millimeters. So I know my side is going to be 50 millimeters. I know the height of the triangle is 43,3. So we've got 50 and 43,3. So I've got times 50 millimeters times 43,3 millimeters. And remember, the depth of the chocolate was 10 millimeters. Guys, all I've done is I've taken my formula, found the bits that were on the diagram, and slapped those numbers into the formula. And then it's straightforward. Okay. So what's my answer going to be? Well, we're going to say, right, so we've got 0.5 multiplied by 50 multiplied by 43.3 times the depth of the chocolate, which was 10, okay, which gives me 10,825. 10,825 what? Millimeters cubed. Why cubed? Because I'm dealing with volume. So which chocolate required more, which shape, rather, required more chocolate? My circular chocolate, okay, or my triangular chocolate? Right. Well, the triangular one was 10,825, and my circular one was 10,700. So my triangular chocolate little chocolate shape needs more chocolate inside it. Right, what's my next question? My next question is, calculate the total surface area of a round chocolate. Let's go all the way back again to my initial question. Let's have a look. So we've worked out the volume of the cylinder. We've worked out the volume of a triangular prism. Now we're asked to calculate the surface area of the round chocolate or of the cylinder. And what is it? It's 2 times pi times r plus h. Okay? So 2 times pi times r. Let's get there quickly. So it's going to be 2 times pi times r times, what was it again? Let's just make sure, okay, times r plus h. So we go all the way, find it quickly, times r plus h. Okay, now we should remember some of these measurements. 2, the question does say always use 3,14. Times, what was the radius of my round chocolate? Here it was 18,5 millimeters, and remember the depth was 10. So 18,5 millimeters. So I'm going to say times 18,5 millimeters times my radius 18,5 millimeters plus the height, which was 10 millimeters. Right. Exciting things now. Once you've got this far, folk, it's just so straightforward from there. Because now all we've got to do is just push those buttons into the calculator. But be warned. Right. Be warned. Guys, check that you're pushing the right buttons on the calculator. I know that sounds stupid. I know that sounds basic. But do you know how many students in their final matric paper will get to an equation like we've got on our screen, and then all they've got to do, push it into their calculator and get the answer, and that's where they go wrong. So let's go for it. So on my calculator now, and maybe you want to just do this part first. Okay, so you could say equals 2 times 3,14 times 18,5 millimeters times 18,5 plus 10 is going to give me 28,5 millimeters. Now, let's just do it in a calculator. Right, so we've got 2 multiplied by 3.14 multiplied by 18.5 multiplied by 28.5 equals, my answer, 3,311,13. So 3,000, already forgotten, let's try that again, 311,13. Comma 13 what, folk? We're dealing in millimeters, but we're looking at area. So that's the surface area of my round chocolate. Okay. In other words, if I took that chocolate and I decided to paint it, and you know you get that lovely paint that you can eat, it's edible paint, right? If I were to paint that chocolate on the outside, I would be painting 3,311,13 millimeters squared worth of area. What do you think our last question is going to be? Let's just look at the formula quickly. So far in our question, we've used volume of a cylinder, the surface area of a cylinder, we've used volume of a triangle. We haven't yet used the total surface area of a triangular prism. And I bet that's going to be our next question. Let's just have a look at it quickly. Calculate the total surface area of a triangular chocolate. Didn't we say that was going to happen? Of course we did. Why? Because the examiner's given us these formula, so we know we're going to use it. Right, so what was that formula? Let's go quickly and find out what it was. It's going to be, the total surface area is side times h. Let's just get that down quickly. So it's going to be side times h equals side times h. And then the question went on and it then said plus 3 times the side times the big H. Okay, side times the big H. So again, plus 3 times the side times the big H. Now, how long was each side? Remember it was 50 millimeters. Okay. Times h, we'll come back to that, plus 3 times, the side was 50 millimeters, times, and the chocolate was 10 millimeters thick, wasn't it? Okay. How high was that chocolate? Do you remember that? Let's just go back and double check ourselves. The height of that chocolate was, where is it? 43,3. So we're just going to put in the 43,3. And then we just need to calculate that using our calculator. Let's do it quickly, and then we're going to take a quick ad break. So I've got bracket 50 multiplied by 43.3 close bracket plus 3 open bracket. And let's just check. We had 50 times 10. 50 times 10, close bracket, equals, and my surface area is 3,665. 3,665 what? Millimeters squared. Why squared? We're calculating area. So, seems complicated, hey? But it's actually straightforward if you remember what I've said. Examiner gives you a formula, yes sir, I'm going to use that formula. Let's take a break. Welcome back, folk. Remember, we're looking at areas, perimeters, volumes, great section of work. And what we've been doing today, we've been looking at last year's exam paper, the 2011 final paper. So what we're doing today, folk, well, it's important stuff because the examiners that are examining you this year probably had something to do with this paper. So we want to make sure we're understanding their type of questions that they're asking. We're probably also trying to understand their style, and that's why it's important to do so many past papers. In grade 12, at this stage, let me tell you this, in order to be doing your revision, you shouldn't be having textbooks open and learning things, okay? You should just be doing past paper after past paper after past paper. Yes, using your textbook to guide you through it, but guys, that's what we should be doing. You should have a whack of past papers from 2008, 9, 10, and 11 paper in front of you, working through them. And I've told my students that for the paper one, before they write their paper one, they've been given the 2008, 2009, 2010, 2011 paper. I expect them to do those papers at least twice each. At least twice each. Okay, so it's 3 hours, 6 hours, 9 hours, 12 hours, doing them again at least 24 hours worth of past papers before they even think of walking into that exam. Ideally, they should do it 3 times. 36 hours worth of work, but well worth it when you get your final results at the end of December or the beginning of January. Right, let's have a look at this question, November 2011, paper 1, and it was their question 4.2. And the question says this: the shoe boxes in which the shoes will be packed have the following dimensions. Okay, so it is from their 4.2 question. So obviously there was a 4.1, but we're focusing on areas, perimeters, and volumes today. So we've just selected this particular question. Okay, so shoe boxes in which shoes will have to be packed have the following dimensions, right? So the shoe box has a length. Let's draw that in here. Here's the length of the shoe box is 27,5 centimeters. It has a breadth, there it is there, of 15 centimeters, and it has a height of 11,9 centimeters. Now, calculate the volume of the shoebox. Use the formula. Volume is equal to length times breadth times height. Guys, clearly this is a paper 1 question. There's nothing difficult about it. They give you the length, they give you the breadth, they give you the height, they give you the formula that says length times breadth times height. All we got to do is slap the figures in, and that's what we're going to do. So, what's the length of my box? The length of my box is 27,5 centimeters. Why? Because the examiner told me so. The breadth is 15 centimeters. Again, why? The examiner told me so. And the height is 11,9 centimeters. Okay. Equals, out comes our calculator. And we're saying, right, 27.5 multiplied by 15 and multiplied by my height, which was 11,9 times 11.9. Equals, and we're going to get an answer of 4,908,75. 4,908. 4,908,75 what? Centimeter cubed. Why cubed? Because we're dealing with volume. Right? What's that actually mean? That means that if I made a little box, right, 1 centimeter long, 1 centimeter high, 1 centimeter in breadth, so a tiny little box, I could fit into a shoebox. I could take those tiny little centimeter blocks, I could fit in 4,708,75 of those little blocks inside a shoebox. That's what volume is all about. What's my next question? My next question is this. The shoes are packed on shelves. the height between the shelves is 118 centimeters. Okay? Determine the maximum number of shoe boxes that can be stacked on top of each other in a single pile between the two shelves. Right. So, you know what it's like, especially you ladies. You walk into a shoe shop and you see a shelf, and it's piled with boxes of shoes. Now the question is, how many boxes can I put on one shelf if my shelf is 118 centimeters high? Well, first thing we've got to know is, well, how high is one shoebox? And remember, we were told that, hey? Here it is. The height of a shoebox is 11,9 centimeters. So my shoebox here, one of them, that height here, is 11,9 centimeters. That's the height of one shoebox. So if one shoebox is 11,9 centimeters, how many of those 11,9 can I fit on top of each other until I've reached a distance of 118 centimeters? Well, it's straightforward, isn't it? We're going to take 118 centimeters and we're going to divide it by 11,9. So let's do that. We're going to say, right, 118 centimeters is the distance of my shelf. We're going to divide it by 11,9 centimeters to see how many of these we actually fit in. And again, folk, our calculator is going to do that for us. So we got 118 divided by 11.9 equals. Now, we're going to get a fun answer here, hey? Look at this answer. 9,915. Let's write that down. So we're going to say my answer, and I'm going to do it in a lovely color. 9, what was it? 915. All right, so 915 and a bit 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 and a bit. And the number carried on and on and on and on. Right, so here's the question. And this is a lovely type of question. I enjoy these questions, and my class know I love giving it to them. So the question is this. First of all, we know our answer is 9,915. We can't put 9 of a box into a shelf. That can't happen, folk. Why can't it happen? Because if we put 9 of a box, what we're actually saying is we've got the shoe box, let's just cut part of it away. You can't do that. Why? Because in cutting part of the box away, we could be cutting part of the shoe away, and no man wants to walk the street with half a tacky. Okay? And no woman wants to wear high heels without the high if you've cut it off. So we can't fit in 915 of a box. So here's the problem. The problem now is this. Am I going to put 9 boxes within that area? Okay, so am I going to stack 9 boxes on top of each other? Or am I going to put 10 boxes on top of each other? Well, folk, if I put 9 boxes in that shelf, okay, I'm going to have a little gap. But that happens in life, doesn't it? Okay, you think of the shelves in your